Now let's just move on to some of the problems that are related with the trigonometric identity. So the very first question says, write all the other trigonometric ratios of angle A in terms of secant A. What does it mean? It means that we have to convert all the trigonometric ratios into the formation of secant A. So let's just start with it. How we can form all the trigonometric ratios into the formation of secant A? We can do this with the help of the trigonometric identities. Let's just see how. Since we know the very first trigonometric identity, it is nothing but sine square A plus cos square A, which is nothing but is equal to 1. And further, I can write this particular trigonometric identity as sine square A is equal to 1 minus cos square A. Definitely, I can write this in this particular format, in which I just have transposed cos square A toward the other side. Now, further we know that we can convert the cos square A into the formation of 1 by secant A. We can write this. Why so? Because we know that cos A is nothing but is equal to 1 by secant of A. So we can write them in such a manner. Now, since it is a whole square, so we can write this as a whole square. Now, let us suppose if I am further solving it, this is sine square A, which is equal to 1 minus 1 by secant square A. Let's just sort it out. This would be nothing but secant square A minus 1 divided by secant square A. Now, let's just sort it out again. So, sine of A would be nothing but the square root of secant square A minus 1 divided by secant square A. Further, we can write this as nothing but square root of secant square A minus 1 divided by secant of A. I'm just taking a square out of the square root. This is secant A. So hence you can see over here that sine of A is actually coming out to be into the formation of secant A only. This is secant square A minus 1 divided by secant square A. So let us suppose if I'll write it again. So this would be nothing but is equal to square root of secant square A minus 1 divided by secant of A. So this is nothing but my first conversion in which I have converted sine of A into the formation of secant of A. Now let's just move on further and talk about the other. So again, if I'm just talking about cos of A, so again we know that cos of A actually is nothing but is equal to 1 by secant of A. So we just do not have to do anything for this because it is already converted into the secant of A. Now let's just talk about tan of A. We know that tan of A is actually nothing but a ratio of sine of A divided by cos of A, and we already know the value of sine of A. Sine of A in terms of secant of A can be written as a square root of a secant square A minus 1 divided by secant of A whole divided by cos of A can be written as 1 by secant of A. So as you can see, secant A are getting cancelled with each other, and at the end we are getting the secant square A minus 1. So this is nothing but the conversion of tan of A in terms of secant of A. Now let's just move on further and talk about the other angles, means the other trigonometric ratios. We have cosec of A, means cosecant of A. We can write this as nothing but 1 by sine of A. And since we know the value of sine of A, this would be nothing but secant of A divided by square root of secant square A minus 1. So this is my second conversion. Now let's just talk about secant of A. Secant of A is definitely remains secant of A. So let's just talk about cot of A. Cot of A is nothing but 1 by tan of A. So we can write this as nothing but 1 by square root of secant square A minus 1. So hence this is nothing but our answer, in which we have converted all the T ratios, all the trigonometric ratios. We sometimes also call the trigonometric ratios as T ratios. So here we have converted all the trigonometric, that is T ratios, into the formation of secant A using the trigonometric identity sine square A plus cos square A is equal to 1.